Hello, everyone. Welcome to the Healthcare and NLP Summit. This is Veysel from Johnson Labs. I'm the head of data science leading the Healthcare and NLP team at Johnson Labs for the last 4 years. So today's keynote, I'm going to cover my topic of like answering patient level questions from raw clinical data. Um, let's start. So, the data generated and exchanged in a healthcare domain may come from various resources. And then, as you can see from my screen, it's a quite complex ecosystem that key decision makers usually are not able to see the entire picture. So, that's why there are many different softwares, automation tools, LLMs out there to automate this process, which are still failing at some point because the data generated may come from different resources as well as different devices, different locations, different physicians as well. So that's why the language generated in one domain, in one center, may not follow the same pattern or same format, or may not kept the data may not kept in the same format in the other centers. So the key idea behind storing all this data to make clinical for the clinical decision making process is putting the clinical facts on a timeline. This is usually the first step, because whenever a patient visits a clinic, there are certain sorts of notes are generated depending on the type of the visit, right? So whenever a patient visits a clinic, a physician makes some decisions, and usually he or she checks the entire history of the patient by checking all these records that are already put on a timeline. So this is quite a tedious process, by the way, as you know. So, but the problem over there is that data is not always structured, right? So data, as you remember from the previous slide, may come from various resources, and most of them are usually unstructured text. If you are lucky, there are some structured text as well, but the format, the schema is also different from venue to another venue. So that's why even if you have a structured data and then try to merge it with the unstructured data and then kept into one single format, you still have a hard time to do this. That's why there are certain tools over there to make this work for everyone so that you can exchange your data. So you start with the first row, it's an unstructured EHR data, and then you try to map it to the common data format. It might be FHIR, it might be OMOP, it might be knowledge graphs. So it might be any format that you use, because the key idea behind this is to be able to have a format that you can utilize for analytic purposes. Unfortunately, the systems used to generate health data in hospitals or in healthcare facilities are designed for operations, because the idea is to saving the life. So the data may not be organized effectively for research or analytics purposes. So when you have the data in a common format, we put them on a temporal sequence, like put them on a timeline, and then try to answer the questions like identify patients diagnosed with a brain aneurysm who also underwent head CT scans, or identify patient who experienced a heart attack and also used drug YXC, right? So to be able to answer these questions, you need to have some structured format so that you can write some queries in a structured languages, or with the latest LLMs or fine-tuned models, you can even do this with some spoken language. So that's why today we are trying to cover how you can go from unstructured text to a well-defined OMO format, and then to be able to answer your questions, ask your questions in a spoken human language. So, but ideally, what if you could do this in a chatbot environment, right? With the advent of ChatGPT and all these large language models who are doing really well when it comes to reasoning text and text generation, human-like plausible text. Imagine that you are asking these kind of questions on a chat UI, which is sitting on top of millions of healthcare records for a certain patient, right? So that you could be able to get aggregated results and then make some reasoning. Of course, this process is not easy, because out of the box chatbots over there are using their own parametric knowledge, right? So it says like some of them are, of course, some mixture of different expert models, but most of them, they don't have an access. Almost all of them, they don't have an access to your own data, right? Even if they have they have an access to your data, it's quite impossible to fit the millions of records into the context window of a large language model. So to as a solution to this one, there's a RAG approach, retrieval augmented generation approach, that you can index your own documents, but it is still you cannot index millions of records. You can index, but you cannot. But you cannot query this via reg architecture, because to be able to answer the question like give me all the patients who have type 2 diabetes using metformin, etc., you need some aggregated data. But if you index your data in a reg framework, you index the simplets, which means that you just ask a question and then you go ahead and then find the most similar simplets and send all the simplets to the LLM to answer your question. So to answer such a question, this approach will not suffice as well. So the solution, there are two solutions. There are two trends over there right now. So if you have an unstructured and structured bulk of data, you can create a knowledge graph, or you can create some structured DB, like some OMOP format or some mimic format, some SQL database format, right? Some schema you can follow, whatever you want. So the idea is to go from unstructured text and tables and structured tables to this format, so that you can ask questions to your DB, to your graph directly. And then this would allow you to answer the questions that you have seen in the previous slides. So today's main topic will be how to do this through OMOP schema. OMOP is an observational medical outcomes partnership common data model, which is trying to enhance the healthcare data since 2009, and which is sponsored and then developed, maintained by Odyssey community. Odyssey is an international collaborative whose goal is to create an open source environment so that the data can be exchanged through across various institutions in a better way, so that this observational data can be used for analytical purposes. So the idea, in short, like TLDR, the idea in OMO format is to convert complex EMR data into a standardized format so that it could be used on a patient level across different institutions. OMOP is adopted by more than 80 different countries, because this is not an official organization, right? This is a community that is trying to adopt this common data model. And as you can see from this map, there are 21 different time zones, like over 6 different countries, and then there are more than 80 different countries who already index more than 900 million unique patient records, which means that there are already more than 1 billion patient records stored in OMOP format around the globe. So in OMOP, there are 7 categories with 39 tables and more than 400 different fields, columns, let's say. So this is quite cumbersome process if you want to go from your data format to this format, because you need to, as you can see here, even if one single term, clinical term, let's say atrial fibrillation, you need to find its parent and child concept. You need to map it to the certain terminologies like SNOMED, ICD-10, ARIS-norm, and you need to find the hierarchical relationship between all these concepts, because you are trying to standardize your data to be able to use in the same manner in every institution, right? So that's why you need to map this to a well-known, internationally accepted, adopted terminologies like MEDRA, SNOMED, UMLS, ICD, ARIS-norm. So OMOP is trying to automate this process, like standardize this process with all these 39 tables. That's why if you try to map just one single node into an OMOP, you need to go through all these stages one by one, which is quite tedious job, as you may see. So to illustrate this point, I just pulled up one of the papers that are published last year to explain how Estonian health community try to transform their health data into an OMOP format. So they pick from 3 different databases, and then they try to convert 18 million records belonging to 150,000 patients, 150,000 patients. So which means that one patient usually around 120 records. So and then they managed to transform 100 million records to like entries to standard concept. Entries means that all these, like a disease, drug names, etc., which means that you need to map this precisely. They managed to do this, but it took so much time and money for them to do this. So what if you can do this by using healthcare NLP tools like NLP tools or machine learning models that we have been using everywhere in our life nowadays, right? Johnson Labs has several libraries, as you know, to do this, which is the flagship library is the healthcare NLP library. And then it has more than 2,000 pre-trained models to be able to accomplish this goal, right? Like imagine this sentence, like one single sentence, you can extract all this information from this sentence by using all these pre-trained models out of the box. So OMAP perfectly fits this situation, right? So you can, if you have one single node, you can just extract all these nodes and then map them into different concepts and terminologies easily. Of course, it is not as easy as out of the box solution, right? Because there are multiple tools provided by the library. There are other libraries who could do this kind of entity extraction or mapping as well. But if you want to stick to one single ecosystem, which is healthcare NLP by Johnson Labs, you could do this easily within the same pipeline at scale because it's sitting on top of Spark ecosystem that you can parse millions. Even Estonia, such a small country, right? There are more than 18 million records generated in 2 years. So you can do the math and then see that you really need a scalable solution to be able to both accurate and scalable solution to be able to accomplish that goal. So the goal in short is that taking all the unstructured and structured EHR data and then map into an OMOP schema. So that format, of course, how you do this, rather than manual, you can code this up. And then there are pipelines that we suggest right now. So you can use all these pre-trained models, put them in a pipeline, and then write a bunch of scripts, and then you will be able to go from left to right without much effort. So as I said, there are pre-trained healthcare NLP models that you can pick to fill up certain tables because each model will return different set of entities, relationships, terminologies in any NLP libraries. So, and then on the middle column, you see the tables that will be populated by the entities on the left-hand side. Once you populate these tables, as you know, there are 39 tables in OMOP data format. So you can go ahead and then generate other transactional data which are generated from these tables. So this is just a subset of entire process for the illustrative purposes. The entire process is non-trivial. So this is a sample table that we just pulled from one single node, like we pick one patient and a few nodes, and then we extracted all the conditions, drug, procedures, and then we map them into an ICD-10, ICD-10 PCS, IXORM, so that we generate all the data points that OMOP requires. From this point on, the rest of the process is writing some bunch of scripts to write the right information to the right field in the right table. So there are different tools to be able to use this, right? Like Athena is one of them that you do manually, by the way. You query your concept and then you find it's SNOMED code, and then you try to map it into the right table in the OMOP. So here, one single sentence, there's a like term FIP. So if you use NER model, named identity recognition model, to find this as a condition, you can map this to a SNOMED resolver so that you will end up with the concept ID and concept code easily. So you can do this with the library rather than visiting the website. So imagine a single, like a few sentence on the upper left corner, so that you can see in any discharge note. So the idea is to find all these highlighted concepts and then map them into a standard formats. So you need tools to do this, right? So in healthcare NLP library, that's what we offer. So given this text, you extract all these entities and then map them to different concept IDs and concept codes, and then you build the relationship between the tables because you need to draw the entire picture, right? There are different tools. Let's say you have this format right now. Now you need to query this. To be able to query this, you need to there are various solutions already offered by the community. Some people write from scratch because it's a structured, like a relational database, right? You can just write a query, a SQL query from scratch. Some people use ODC generated query library on the bottom left corner. So there are some pre-built queries that are mostly used by the people. So you can just pick one of them rather than writing the scratch. Or there are some tools like Atlas. So it's a unified interface. These are all open source, by the way. But each one of them you need to do some manual processes. You need to write code, or you need to pick the fields, and then these are all exact, which means that you need to be exact while trying to build your own query. There are, in the last few years, there are certain trends like natural language to SQL libraries. So rather than writing the query from scratch, you can use spoken language and then convert, because in LLMs especially, right? So you can have a sequence to sequence translation. So you can have a natural text input as an input, and then you may end up with an SQL query. But given 39 tables and more than 400 fields, this solution is also really, really hard to achieve. Right. So what we did at Johnson Labs, we published a paper by using Mimic SQL dataset. Before even OMOP, we have been working on this, by the way, for the last 2 years. And then we managed to publish it last month. It's going to be published in Artificial Intelligence and Health Journey. And then we offered a solution over there for such a high dimensional schemas, some schema pruning, and then finding and then only dealing with the field names and table names that the query requires. So in this paper, we saw that even the small language models, like less than 1 billion, can beat GPT-4 or 20 billion size models easily if you do the schema pruning without any schema provided within the prompt. So since we don't have time, I'm not going to cover this, but we will have a paper that you can read. So with this approach, we combined large language models, actually small language models. We didn't even need to use large language models over there. We noticed that by applying this approach, you can significantly surpass the zero shot or few shot capability of GPT-4, because out of 39 tables, zero shot, even if you provide the schema to GPT-4 in a prompt, it will probably not be able to focus on key schema elements. So here's the outcome. You have a simple text, simple query. How many patients having angioplasty also use Plavix? This is your query. By using healthcare NLP, what we do is that we find the procedure and drug names at first with the name identity recognition models. We map them to the concept ID and concept codes by using our entity resolutions, and then we send it to a text to SQL model, and then it generates this query at the end. So here is one of the simple example that we run against OMOP schema. So how many drugs exposure were recorded for each person? So and GPT-4 put the schema in the prompt, because in each LLM, in our approach as well, you need to provide the schema because otherwise you need to fine tune, right? Or you give a fifth shot to make the model understand the schema. So as you see, ours can perfectly capture the essence of this query, while GPT-4 fails to do this. So that's why with small LLMs, even with less than 1 billion parameter models, if you apply these different right techniques and then different pruning techniques, you will be able to achieve nice accuracy without even fine-tuning on this data set. Because to be able to fine-tune an LLM on any SQL dataset, you need to generate a bunch of SQL queries, as you know. So this approach will allow you to do this without fine-tuning your LLM. And then another approach, which we also accomplish, but I'm not going to cover right now, is you can also do the same with the knowledge graph. You can use NLP components to generate knowledge graphs. You can extract entities, build the relationships, map them into certain terminologies, and then augment the knowledge graph with other knowledge bases out there. And then you can ask a question in plain text, then do the text to cipher, because in knowledge graph there's this is Neo4j, so there's a cipher query which is similar to SQL query that go from free text to SQL query. So if you're able to do this, you can grow your graph every time a new patient or new record arrives, and then you will be able to ask complex questions over millions of patients. It's like a patient level querying. I hope you enjoyed the session. I'll be around to answer any question if you have any. Thanks for watching.